Hello, this is the luckiest maths teacher in the world. Today we're looking at similar triangles. So similar means the same thing that it did last lesson. Remember, two shapes are similar if all sides are in proportion and all angles are equal. Now, we needed to test all that last time, but there are some shortcuts that you can use just when we're looking at triangles. So for triangles, to determine if they're similar, there are 4 tests. So the tests I'll write for you here: SSS, SAS, RHS, and AAA. So here, S means a side in proportion, A means an angle equal in each of the triangles, R means right angle in both of the triangles, and H means hypotenuse in proportion. That's, of course, the longer side of a right-angled triangle. So one other thing I just need to note is for SAS, it has to be 2 sides in proportion, but it must be the angle between them. Otherwise, this test doesn't work. So what do all these tests mean? They're shortcuts to determining whether 2 triangles are similar. So what this first test is saying is that if all 3 sides are in proportion, then the triangles are similar. Now that's a shortcut because I told you that similar means all sides are in proportion and also all angles are equal. It turns out for triangles, if all 3 sides are in proportion, then all 3 angles will be equal, and so we know the shape is similar without needing to test the angles. This test here, AAA, sort of means the opposite. If all 3 angles in 2 triangles are equal, then their sides will be in proportion. Then they will be similar. So if all 3 angles are equal over 2 triangles, we don't even need to test whether their sides are in proportion. So let's look at an example of these tests. So let's look at these 2 triangles here, and I want to know whether or not they're similar. Well, I've got information only about their sides, so I can look at the proportion of their sides. So I know that 12 over 8, so this side divided by its corresponding side is 1.5. Obviously, 12 over 8 is also 1.5. 15 divided by 10 is also 1.5. That means that each of these sides are in proportion 1.5. Each side in this triangle here is 1.5 times as long as its corresponding side in this triangle. This means that all 3 sides are in proportion. So that means I know that these 2 triangles are similar by the SSS test. I don't need to go and measure angles or anything like that. Because I've used this test here, I know the 2 triangles are similar. Let's look at another example. So let's look at these 2 triangles here. Well, I know they both have a right angle, so that's what the R stood for in one of the tests. Now, I know that 100 divided by 50 is 2, 60 divided by 30 is 2. So that means the hypotenuse and another side are in the same proportion. So I know that these 2 triangles are similar by the RHS test. I don't need to know the lengths of these sides here. I don't need to know this angle and this angle or this angle and this angle. I've done enough to know that these 2 are similar. So I'll just look at the SAS test. It has to be 2 sides and the angle between them. So let's say we have weird looking triangles like this. So sorry again, I know I'm not the best drawer. Okay, so let's say that I know that this side is 25 and this side is 5. This side is, say, 30 and 6. So these 2 sides are in proportion because 30 divided 6 is 25 divided 5. Now for them to be similar, I have to be told that this angle is the same as that angle. It has to be the angle between them. So if I say that this angle's 30 and this angle's 30, these 2 triangles are similar by the SAS test. two sides in proportion, and the angle between them. So again, I don't need to test all sides and all angles. I've just used one of the 4 tests. Alright, the only other thing we need to know is how to find the length of a side using the scale factor. So in this example, I'm going to use similar triangles and scale factor to find the value of an unknown. In this case, I'm looking for x, the distance from here to here. This 18 is the distance from there to there. Okay, so firstly, these two triangles are similar. The reason I know they're similar is actually A, because they have this angle equal, so that's the right angle in both. Even though I have the hypotenuse, I don't have another side to make sure that it's in the same proportion as the hypotenuse. But I do know that this angle and this angle are equal. If two angles in a triangle are equal, the third angle must also be equal because they add up to 180 degrees. So these two triangles are similar because of the AAA test. Now, because they're similar, all sides will be in proportion. So first I have to find the scale factor. Now, the scale factor, you've got to be careful. I've got to make sure that I line up a side with its corresponding side. So this 30, which is the hypotenuse, corresponds to this one here. This triangle can be flipped over this way so that it sort of lies on top of the other triangle. So the scale factor here is 30 divided by 20, which is 1.5. That means that to get the length of a triangle, the length of a side in the larger triangle, which is this one here, I take the corresponding side in the smaller triangle and times it by 1.5. So we're going to use that to find what x is. Now the difficult part here might be figuring out, does this x correspond to this side or this side? Now you probably think, a lot of people would look at this and think, okay, x and 18 are corresponding because they're on the same line, but they're not. Notice that x is touching the dotted angle and the right angle. So it actually corresponds to this side here, which is touching this angle and the right angle. Okay, it's touching two equal angles. The side that's marked 10 is touching these two angles, and x is touching two angles of the same size. So x corresponds to the side marked 10, not the side marked 18. So x, how do I figure it out? I take the side in the smaller triangle and I multiply by the scale factor. So x will just be 15. Okay, I hope you've enjoyed this video. This has been the luckiest maths teacher in the world. Have a great day.